Hi, we've got our Chapter 2 notes packet. Let's get our name on this packet and start filling in the dates that go along with our specific period. For instance, today is Friday. For those of you that like to put the date down, it's the 13th. Eek, Friday the 13th. Go through the rest of the calendar and fill in the days that go along with your period. If you're fourth period, well, we don't meet on Thursdays. If you're eighth period, we don't meet on Tuesdays. Do that for the following week as well. When you're done with that, unpause the video. There will be moments where you're following along and other moments where you need to pause the video so that you have some time to catch up or practice a problem on your own. So make sure you pause it at the right moments. Right now, though, we're reading along. And we're looking at 2.1, Inductive Reasoning and Conjecture. That is how you say this word, conjecture. Conjecture, for our purposes, is going to mean that it's an opinion based on incomplete information. But it's not just any opinion. We're going to have a reason for this opinion. We're going to have a justification for this opinion. We're going to practice this with pictures at first. And if I look at problem number 1, I am asked to write a conjecture. That's going to be a statement that we write down here. And that is going to be describing the pattern in the sequence. We're going to also include the next two figures in the sequence. I'm actually going to start by drawing the next two figures, and then I'm going to write my description. So let's start by drawing the next arrows that we have here. Well, I see that I have an arrow facing upward. And then this arrow is going to, not quite the left, but a little bit. And then it goes exactly left. And it seems to be kind of spinning around. So what I'm going to do is to make a guess. It's going to be my opinion on what the next one is. But again, it's not based off of no information. I can't just decide that, oh, I feel like the next one is going to be right here. I have to have a reason that I think the next one is right there. Actually, I don't think the next one is right there. I think these arrows are kind of spinning. This was up, and then it went to the left. Then it went down, and I think the next one is going to be exactly right. And then I think it's going to keep spinning. And the directions ask me to draw the next two. So really, I'm claiming those are my next two. Well, the conjecture is going to explain why I think this is the pattern. Ultimately, you're going to feel like we're explaining what the pattern is. I'm going to say that I rotated, or maybe you were thinking about spinning. Both of those are good words. The arrow. I'm going to say left, or a really common word that's going to be coming up is counterclockwise. But I'm not just going to stop there, because if that's all you rate, that you rotated the arrow left or counterclockwise, then it doesn't say by how much. You could rotate it just a little bit. So for instance, from this first one, the second one could have just been a little more, and then a little more, and then the next one just a little more down, a little more. That's not what was happening. So I have a reason that I pointed it the direction that I did, and it was because these were moving, or rotating, or spinning 45 degrees at a time. So I'm going to try to be specific. Let's look at the next picture. I have a pattern started for me, and in the end, I'm going to try to describe the pattern right here and why I think that's the pattern. Well, the pattern, I don't know. Why don't you pause it and decide what you think the pattern is going to be, and then unpause it and see if we agree or disagree. Did you say something similar to this for the next one? At this point, I feel like the shaded triangle is moving clockwise. But here's something that we may or may not agree with. Where did you put the next one? Did you put it back to where the first one started? I can understand that. Or did you decide that it should go into the middle? And that would be the next part of the pattern. I can understand that as well. So here's a good example of how we can have different answers, but justification is going to be really important here. What I would have a hard time with is understanding how this would be the next one in the pattern. Maybe it would come up later, but it's not what I would say would be the next one in the pattern. I want you to try the next example, problem number 3. And I'm going to be really interested in what you say that the conjecture is, and I want you to make sure that your conjecture really does match what you're telling someone to do to get the next pattern in the picture. Pause this and try it when you're done. Do you have something like this? I think this conjecture is okay, but I don't love it. I wouldn't give it full credit, and here's why. Adding one more to the bottom row every time will be helpful, but really, the person who does that from the last example, well, all they're doing is saying that if this were the third one, that if I add one more to the bottom row, I would have 1, 2, 3, 4 on the bottom row, and then it doesn't say to do anything else with the rest of it. And I don't think that's what we mean. This would be what our picture would end up looking like. So we've got this triangle here, and I added one more to the bottom row. I think what we mean is add one more to the bottom row every time, then complete the triangle. That would be a conjecture that I like better. Alright, pause this and take 2 or 3 more minutes. Complete 1, 2, 3 more questions on this page, and then start it up and we'll go to the next page. Instead of diagrams and pictures, we now have numbers. The conjectures are going to work the same way. We're going to describe the pattern. A typical pattern is going to use addition, subtraction, multiplication, stuff like that. I'm going to give you some time to work on these, but before we do that, I'm going to jump to one of the later problems. I want to work on problem number 11. In problem number 11, this is quite the pattern. Can you figure out what's going on here? If you're a little confused, look at this. What do these numbers do for the next number? Does that work the next time? Does that work the next time? If you can figure out the pattern, fill it in, and write a conjecture. If not, maybe do some other problems on this page first. And again, the hints are that you typically use things like addition, subtraction, multiplication, and division. Pause the video and take about 3 to 5 minutes to do as many problems as you can on this page, and then start it up again. Now we're going to look at another style of question. This time, the conjecture is given, but we have to finish the conjecture. And in order to convince me of this, you're going to have to list 1, 2, 3 examples. If you need more than 3 to understand it yourself, then put more than 3. But I'm going to require a minimum of 3 examples, even if you don't need any examples. Well, let's see how this could work. We have this statement. The sum of 3 even numbers is what? First of all, a reminder, even is 2, 4, 6, 8, etc. And sum is a fancy word for addition. So the sum of 3 even numbers, I'm going to take 2, 4, 6, and let's see, those add up to 12. I said 3 examples though, so I'm going to pick 3 other even numbers. I'm going to pick 2, 8, and 100. That's 110. There's nothing saying that they have to be different numbers, so I'm going to do 2 plus 2 plus 16. 16 gets me to 20. All of these numbers end up being even. See if you can figure out the next one, and then we're going to talk about what a counterexample is. It's important that we take time to note that conjectures are not proven statements. Just because we have a few examples does not prove that something is true for every case. It just worked for the ones that we tried. However, it does give us a better idea of what might really be true, or it tells us what is not true. And that not true is what we're leading into right now, a counterexample. A counterexample is an example that shows the statement is false. So before, everything we've had so far was true. Now I'm going to make a statement. It's going to be wrong, and you're going to say, well, wait, that's not true, and I'll show you why. And the counterexample is your example of why what I'm about to say is wrong. We're going to start with a math example. The sum of 2 numbers is always greater than the larger of the 2 numbers. It's kind of a lot there. The sum of 2 numbers, I'm going to pick the 2 numbers 1 and 3, and their sum is 4. This says the sum of 2 numbers is always greater than the larger of the 2 numbers. So 4 is greater than 3. Well, that seems to be working, and this is supposed to be a counterexample, meaning what I just said was wrong. Well, let's think about this. What if I take, instead of 1 plus 3 equals 4, I'm going to use a negative number. What if I take 2 and add it to negative 5? That gives me an answer of negative 3. Well, the sum of 2 numbers is always greater than all the other numbers. Well, negative 3 is not bigger than positive 2. So what I just drew here was a counterexample showing that what I just claimed here was wrong. Can you think of an example for number 16? It's not an algebra one, it's a geometry or a shape problem. And then try number 17 and start it up again. So what you want to understand here is that there's going to be a lot of statements that are true, and we're going to be talking about them. But there's going to be some that are false as well, and you're going to have to explain or show or prove to me why it is that they are false. If we go back to your assignment page, it says that your assignment is actually in our notes. First time that's happened all year. And you're going to finish pages 3 through 6 of our notes. If you finish this in class, show it to your teacher. If not, you'll show it next time that you have class. Good luck!